So where should a handler actually live? There is a clear order and it is worth knowing exactly. First, a tri-scope zone error handler gets first refusal, that is the innermost level and the smallest blast radius, and it is where most of your on-error continues belong, because it lets one risky step fail without touching anything else. Second, if nothing there matched, the flow zone error handler, that covers the whole flow, and remember that if an error reaches flow level, the rest of that flow does not run. Third, the global default handler, declared once with default error handler ref in the configuration element, inherited by every flow that declares nothing. And fourth, if nothing matches anywhere, the error leaves your application and the caller gets whatever the runtime produces, which is never something you want to ship. So always have a catch-all, and then the rule that surprises everybody. A subflow cannot have its own error handler. It has no error handling of its own at all, because it executes inside the calling flow's context. So an error raised inside a validation subflow is caught by whichever flow called it. That is actually useful, because one shared validator can raise errors that every caller then handles consistently. But it only works if you designed for it, rather than discovering it during an incident. Good practice and bad practice, and I want to be direct about which of these actually hurt. On the bad side, an empty on-error continue, the silent swallow, and I keep coming back to it because it is genuinely the worst bug class in Mule. Type any at the top of your handler, which makes everything below it dead code, returning error.description straight to a public caller, which leaks your internals and your component names, branching your logic on error.cause, which the documentation explicitly warns against because it is internal API and it can change, copying the same handler into every flow, so that when the contract moves you have 5 places to change and you will miss one, raising HTTP or Mule types yourself, so nobody can tell your errors from real ones, and the one that costs actual money, on error continue on a step that writes data. Continue means the flow succeeded, so you have just told the caller their order went through while the database write quietly failed. Continue is 4 steps whose failure genuinely does not change the answer. Audit logs, notification emails, cache warming, optional enrichment, never for the write that was the entire point of the request. On the good side, log, then shape, then set status, in every block, specific types first and any last. Catch a parent type when you want to cover a whole family. Use error mapping so 2 identical failures become distinguishable. Put the status code in a variable that the listener reads, so it is decided in one place. Use your own namespace for raised errors. And put a correlation ID in every error log, because that is how you find one request among millions when somebody calls to complain. Transactions, because this is where the choice between continue and propagate stops being about response codes and starts being about your data. Inside a transaction, on-error continue causes the transaction to commit. You told Mule the error was handled, so it believes the work succeeded. On-error propagate causes it to roll back, because the error is still live when it leaves the scope. So continue and commit are literally the same decision, and if you have 2 database writes that must both succeed or both fail, they belong inside one tri-scope with transactional action set to always begin, and an on-error propagate. Put a continue there instead and you will commit the first write, lose the second, and have no error anywhere telling you it happened. On the tri-scope itself, transactional action is indifferent by default, which joins an existing transaction without starting one. Always begin starts a new one. Begin or join does whichever is needed. And the components that behave differently, async runs on its own thread, does not roll back, and an error inside it never reaches your flow's handler at all. Parallel for each degrades to sequential inside a transaction and there is no partial commit. Flow reference is the well-behaved one. It stays on your thread and joins the transaction normally, and errors inside it surface in the caller's handler. Naming. For the global handler, choose global_error_handler or API_error_handler, not error_handler1, not error handler, and never test. For the error types you raise, choose app::validation, orders::too_high, app::backend_down, not app::error, which tells you nothing, not app::e1, and never hijack the HTTP or Mule namespaces. For the on-error blocks themselves, name them for the outcome. Validation @400, backend down @503, not on-error propagate, and definitely not on-error propagate 1. The icon on the canvas already tells everybody what component it is. What the next person needs to know is which failure this block is about and what the caller ends up receiving, and validation @400 says both of those in 3 words. For try scopes, name what they protect, try audit right, try enrich customer, and for the status variable, vars.http status, not vars.s or vars.temp. So let me put the whole decision in one place, because this is the part you will come back to. Use raise error when you are the one detecting the problem. A business rule is broken, a required field is missing, a value is out of range. Nothing has technically failed yet, no connector broke, but the request cannot succeed and you are declaring that early, in a type your handler already understands. Use on error continue when the step was optional and the request genuinely still succeeded without it. Audit writes, notification emails, cache warming, nice to have enrichment, and almost always put it inside a try scope rather than at flow level, so it covers only the step you meant. Use on error propagate when a request cannot succeed. Invalid input, authentication failure, the critical write failed, the essential backend is down. It is also the right choice any time you are in a transaction you need rolled back. Use a try scope to keep the blast radius small. One risky step, its own handler, the rest of the flow untouched, which is how you get surgical error handling instead of all or nothing. And use the global handler as your translation layer at the edge, where every error type that can escape becomes a deliberate status code and a clean by. How many of each? One flow level handler, and usually that is inherited rather than written. 1 to 3 try scopes at genuine failure points. And as many raise errors as you have business rules, because those are cheap and they double as documentation of what your API refuses. Underneath all of it there is really one question. Bubble or swallow? Propagate bubbles, so the failure keeps traveling and the caller finds out. Continue swallows, so it stops here and the caller never knows. Swallowing is only right when the caller genuinely does not need to know. Everything else bubbles. Now the traps, including several that are not obvious from the documentation. First, and I mentioned it earlier but it deserves repeating, error message holds the real backend response. When an HTTP request fails, the status code and the body the other system sent are in error.errorMessage.attributes.statuscode and error.errorMessage.payload. They are not in error.description. Second, the when attribute is a second filter on top of a type, so you can treat the same error type differently based on a condition. Checking whether the status code was 429 lets you handle rate limiting differently from every other HTTP failure, which is a genuinely advanced move. Third, wildcards work in the type attribute, so HTTP:* catches every HTTP error and comma-separated lists work too. Fourth, unknown is caught by any, deliberately, for backward compatibility, so your catch-all really does catch it. Fifth, a subflow has no error handler of its own and its errors surface in the calling flow. Sixth, and this one is dangerous, an error inside an async scope never reaches your flow's error handler, because async is on a different thread. If you need to know about failures in there, you must put a handler inside the async block. Seventh, scattergather aggregates failures into composite_routing and you iterate error.child errors to find out which route actually broke. And eighth, log the correlation ID in every error message, because that is how you trace a single request across several applications. Two of these bite hardest in production: async swallowing silently, and the empty on error continue. Between them, those two account for most of the it just never arrived and nothing was logged incidents you will ever investigate.